Good morning, students. I hope all of you fine now. So today we will discuss the topic here, correlation coefficient for CSE first year second semester students. Your subject code is BSM 201 and mathematics 2A. So before started, at first we will discuss the covariance. What is covariance? Actually, in probability of theory and statistics, covariance is a measure of the joint variability of two random variables. If the greater values of one variable mainly correspond with the greater values of the other variable and the same holds for the lesser values, the covariance is positive always. The covariance measures the directional relationship between the return or two assets. A positive covariance means that a set returns move together, while a negative variance means the y, suppose they move inversely. So covariance is a measure of the relationship between two random variables. So the covariance is defined as the expected value, and that's why our mean of the product of their derivatives from their individually expected values. So that's why covariance is a measure of the relationship in between two random variables. Suppose we consider x and y. One is x, another one is y, suppose. So now we will discuss the next topic. Our topic this is the correlation and coefficient. So suppose here we consider the three sample space. So consider there are n samples, x1, y1, one sample, another one is we consider second one observation, and last one corresponding to a bivariate sample x and y. Now the covariance of x and y is denoted by COV of. Its denote is COV. Short form is covariance. Short form is COV. COV x comma y, and it's defined by COV of xy equals to 1 by n summation of xi minus x into yi minus y. This is the y bar, this is the x bar. X bar and y bar, what is x bar, y bar? Actually x bar and y bar are the mean of x and y respectively. And here I equals to 1 to n. So that's why x bar and y bar, what is x bar? X bar and y bar are mean of x and y respectively. X and y respectively. Okay. So now after that, to calculate this one, I have to multiply these two terms in bracket of xi minus x bar and in bracket of yi minus y bar. So at first 1 by n summation of I1 to n. I have to multiply xi into yi. This is xi into yi. Xi into y bar minus x bar yi and minus plus x bar y bar. So that's why 1 by n summation of I1 to n xi yi minus individually I have to take in the summation form summation of x bar y bar. So 1 by n summation of xi yi, I is 1 to n. Here y bar, what is y bar? Y bar actually our mean of y, so that's why this is our constant term. So this is a y bar. We can write of this term y bar summation of I1 to n xi minus, similarly here x bar is also a constant term, so that's why we can write x bar into I1 to n yi plus x bar y bar. Now what is x bar? Our x bar equals to mean of x. So that's why we can write x bar equals to actually x1 x2 up to total observation. So total observation is our n. So this is x1 x2 up to xn by total number of observation. This is our observation, and this is the total number of observation. So we can write summation xi by n. And similarly for y bar equals to summation of yi by n. This is the total observation n. This is our question, and total is observation are n samples. So that's why our total observation is n. So summation of yi, that is y1 plus y2 up to yn. I is obviously 1 to n. This is the total observation by total divide by total number of observation. So that's why we can write 1 by n summation of I1 to n xi yi minus y bar into summation of xi. This one is summation of xi means n into x bar. Then we can write n into x bar minus x bar into summation of y. Similarly we can write n into y bar. So this is n into y bar plus summation of x bar y bar. So here summation of x bar and y bar. Summation of x bar y bar means our x bar and y bar totally is a constant term. Here x bar and y bar totally is a constant term. So that's why all of you know that summation of any up to n term, suppose 1. Summation of 1. Summation of 1 means, what do you mean by summation of 1? So that's why suppose we consider the total up to terms is here n. If we consider here total number of terms is n. So that's why is 1 is repeated up to 1 times. 1 plus 1 plus 1 plus. This is the up to n times. So its summation value is obviously n. So that's why here summation x bar y bar, and x bar y bar totally is a constant term. So that's summation of yn xi yi minus 2n x bar y bar plus n x bar y bar. Why? Because our x bar and y bar is a constant term. So then summation of 1, remaining term is here summation 1, and summation 1 means up to n times. This is the total observation is n. So that is the 1 times is repeated to up to n times. So this is n. So now 1 by n summation of xi yi n I1 to n minus n x bar y bar. Okay, so it's another form is curve of xy. Its another form is either this one, curve of xy equal to 1 by n summation of I1 to n xi minus x bar yi minus y bar, or 1 by n summation of I1 to n xi yi minus x bar y bar by n. N is multiplied here. So now, so this is the n, this is the by n, this is also by n. So n cancel, so 1 by n summation of xi yi minus x bar y bar I1 to n. This is our answer, curve of x and y. Next is correlation and coefficient. Correlation and coefficient. We have to denote it. Correlation coefficient is r of xy, suffix r of xy or rho of xy. So the correlation coefficient between x and y is denoted by r of xy or rho of xy, and it's defined by r of xy or rho of xy is equals to curve of xy by sigma x sigma y, or curve of xy by sx xy. Sx and sy are the standard deviation of x and y respectively. Here sx sy or sigma x sigma y are the standard deviation of x and y respectively. Here sigma x and sigma y are standard deviation of x and y respectively. So that's why our rxy formula key, what is the formula? Curve of xy by sigma x sigma y, and our curve of formula is the summation of 1 by n summation of I1 to n xi yi minus x bar y bar. Our x bar and y bar are the mean of the x and y respectively, or another formula is 1 by n summation of I1 to n xi minus in bracket of xi minus x bar and y in bracket of yi minus y bar. After calculation we get this value. Okay, so both are same, and our correlation coefficient formula is a curve of xy by sigma x sigma y. Our sigma x and sigma y are the standard deviation, and that is the short form S dot d. This is the standard deviation of x and y. Okay, so now to go to some important points. Okay, now so what is first of all what is our sigma x? What is the sigma x? Our sigma x, all of you know that is standard deviation of x. So it's what is the formula? It's root over 1 by n summation of xi square, I is obviously 1 to n, minus x bar whole square. This is the formula of sigma x, standard deviation of x, and sigma is the standard deviation of y, and its formula is, in that time our variable is n, y, this is n, summation of yi square minus y by square, I is 1 to n. This is our standard deviation of y. So next is, so therefore our formula is r of xy equals to curve of x comma y divided by sigma x sigma y. So curve of xy means n into, this is a 1 by n into summation xi yi minus x bar y bar, I is 1 to n, divided by 1 by n summation of xi square, I 1 to n minus x bar whole square. This is 1 by n summation of yi square minus y bar whole square. This is the formula. And after that, after simplification, its value will be n summation xy minus summation x summation y divided by n into summation x square minus summation x whole square. This is the one, and another one is n summation y square minus summation y whole square. Okay, either this one curve of xy by sigma x sigma y, or directly you have to use the formula is n into summation xy minus summation x summation y whole divided by root over of n into summation x square minus summation x whole square into root over of n into summation of y square minus summation of y whole square. This is the formula. And now to go to some important points. First point, number one. First one is the correlation coefficient between two data is independent of the choice of the origin. First one is number one, the correlation coefficient between two data is independent of the choice of the origin. So number one. Number two, if two bivariate samples x and y samples x and y and uv are such that u equals to ax plus b and another one is a b, this is a cy plus d, then r of uv, that means is correlation coefficient of u and v, equals to ac by mod a mod c into r of xy. Here what is ruv and what is rxy? Our ruv and rxy are the correlation coefficient of u and v and x and y respectively. So here r of uv and r of xy are correlation coefficient uv and xy respectively. So here if RUV and RXY if equal, if RUV and R of XY if equal when A and C are of same sign, and if A and C are opposite sign, in that time our RUV, that's why our correlation coefficient U and V equals to minus of R of XY. That's why if A and C are of same sign, in that time R of UV equals to R of XY, and if A and C are of opposite sign, then R of UV equals to minus of R of XY. Okay, same sign, these two are equal, opposite sign, so this is also opposite form. Okay, number 3, very important point, this one is the correlation coefficient between two random variables always lies between -1 and +1. The correlation coefficient between two random variables always lies between -1 and +1. Okay, so that is, if we consider ki rho is the correlation coefficient, so then we can write -1 less than rho less than +1. This is the correlation coefficient in between -1 to +1. Okay, it's very important. This one is actually -1 less than and +1. Okay, so now I have to go to the, now we take a problem. Our problem is, suppose we consider number 1, in order to find the correlation coefficient between two variables, our two variables is x and y, from 12 pair observation, so it is our two variables is x and y from the 12 pair of observations, the following calculations were made. Summation of x equals to 30, summation of y equals to 5, summation of x square equals to 670, summation of y square equals to 285, summation of xy equals to 334. On substitute verification, it was found that the pair x equals to 11, y equals to 4 was copied wrongly. So that means our data is all incorrect. This all data are incorrect. Copy wrongly the correct value. Find out the correct value. This is our question. So that's why at first we have to find out the correct of summation x, summation y, summation x square and summation y square, and also summation xy. Total 5 values. Because here the total given 5 values all are incorrect. Summation x, summation y, summation x, summation y square, summation xy. So at first we have to find out the correct summation x, summation y, summation xy, summation x square, summation and y square, last one. So at first, total here the total observation is some 12 observation. This is the given is from 12 pair observation. So that's why our n equals to 12. Summation of x equals to 30 minus 11 plus 10. This is the 29. Summation of y equals to 5 minus 4 plus 14. This is the 15. Summation of x square equals to 670 minus 11 square plus 100 10 square. This is that's why it is 100. 649. summation of this is the 121, this is the 100, and this is 670. After calculation, this value is 649. Summation of y square 285 minus 4 square plus 14 square equals to 465, and summation of xy equals to 334 minus 11 into 4 by this is a 430. Okay, so these all are our correct value: summation x, summation y, summation x, summation y square, summation xy. And now we have to go to the formula. Our formula is r of xy equals to n into summation xy minus summation x summation y by n summation x square minus summation x whole square n summation y square minus summation y whole square. So now your 12 into summation xy is 430, summation x is 29 into 15 divided by root over 12 into summation x square 649 minus summation x whole square, this is 29 square, by into summation n, this is 12 into summation y square 465 minus summation of y whole square, this is 15 square. So after calculation its value will be approximately 77.77. Okay, so this is our correct correlation coefficient value, and obviously our last point is what is the last point? Our last point is always correlation value, correlation coefficient value. That's why our rho value always lies between -1 to +1. So this value is 0.77, and obviously this value lies between -1 to +1. So this is our correct correlation coefficient value. This is therefore the required correct correlation coefficient is correlation coefficient is 0.77 approximately. Okay, students, I hope all of you understand. So today up to this, next class I will discuss the next topic, our regression line. Okay students, now bye, take care, have a nice day.